Hello, this is Kumar Mitra. My presentation is on fraud detection in banking. Let's go over some current methods first. Historically, fraud detection in the banking industry has been driven very much on a rule-based approach. Some common example algorithms out there are k-nearest neighbors, decision trees, and logistic regression that are being leveraged today for fraud detection. Some of the challenges that we face with these approaches. They are supervised learning algorithms and therefore have limitations by nature that learning needs to take place by labels to classify if a transaction is fraudulent or not. The second challenge that we face is false positives are significantly higher. That is, non-fraudulent transactions are categorized as fraudulent, leading to millions of dollars of lost transactions, along with customer complaints. The solution is leveraging deep learning techniques, in particular unsupervised deep learning algorithms. These algorithms do not require to be trained and can detect anomalies in a set of transactions. Autoencoders and restricted Boltzman machines, the RBM, are the two methods that would be the focus in this presentation. So AE, they're a special type of deep learning algorithm. Output is the same as the input. They use many layers for encoding and decoding in the hidden layer. Decoded data is compared to the input data, and if the data is not the same, a gradient descent is activated until a minimum error is reached. In case of fraud, data that does not allow a pattern is detected and flagged as fraudulent transactions. Implementation of autoencoders. One way to implement the AE could be the hyperbolic tangent function, or tanh function, to encode and decode the input to output. Backpropagation is used to compute the error signal and propagate the error backwards through the network that starts at the output units by using the condition that the error forms the difference between the actual and the desired output values. Based on the AE, parameter gradients can be leveraged for realizing backpropagation. RBM is another type of deep learning algorithm which specializes in fraud detection. Learning occurs from the probability distribution on the input data in an unsupervised mode. The main feature, which is also interesting, happens to be that it does not have an output neural layer. It consists of only a visible input layer and however many hidden layers needed. In case of fraud detection, RBM are used where objects are the transactions and the features are all the characteristics that make the transactions fraudulent or not. Implementation of RBM. Each input node takes the input feature from the dataset to be learned. Output of RBM is getting the reconstruction back to the input. There is no true output layer in RBM, if you recall. The point of RBM is in the way they learn by themselves for data reconstruction, and that in itself is an unsupervised learning technique. So let's look at AE and RBM in action real quick. So for an example, let's look at credit card fraud detection using AE and RBM. Consumer orders product on internet using credit card. An issuing bank sends transaction to acquiring bank along with all the information needed. Credit card fraud system is used to evaluate behavior of the credit card. Fraud system requests consumers' profile from the database to bring behavior into the AE and RBM. Based on the AE, acquiring bank transfers the input, that is the money and the time and the location of the internet use. AE uses past behavior to be trained first and then uses the new transaction as a validation test. RBM uses all transactions that transfer from acquiring bank as visible input and then goes to the hidden node. After calculation of the activation function, RBM reconstructs the model by transferring the new input from the activation back to the output or the visible function itself. And that's time. Thank you.